Yeah, it's just behind you, but why? I think.
I just had this for like an hour and it's not warming up, so I'm gonna warm it up. You want me to warm it?
No, I'm not sure about that. You know.
Why? What happened there?
Hot chocolate and still warm.
Wow.
I got it this morning.
You're a lot warmer than mine. I just had this one half hour ago.
Yep.
What's the difference here to the cup?
That's definitely. I'm doing the research about this guy. It's about the polystyrene.
The research about this cup?
Yeah. It's really impressive. You want to have a look about that?
Sure.
Yeah, sure. Well, actually, I'm doing some project about the polymer. Do you want to have a see some details about that?
Sure.
Well, first is a polymer. Polymer is a large molecule composed of repeating structure units. The subunits are typically connected by the covalent bond. Well, the most famous polymer is DNA, which is 2 meters long. That's quite impressive.
Wow.
My project is about polymer and the energy relationship. Polymer can be very useful in the energy industry. Take out your cell phone, it's made by polymer, and out of the battery, it's made by polymer. And polymer is very good for the next generation of the energy, like the solar cell.
So what all this had to do with the coffee cup?
Well, the most important thing about polymer is they're very good at the insulation material. There are 3 materials used for the polymer insulation: expanded polystyrene, extruded polystyrene, and polyurethane. Well, the last two materials is very expensive, and your cup is just made by the expanded polystyrene.
It's cheaper?
Quite cheap.
I see. It looks really complicated molecule. Do you think it's easy to make?
Well, it depends on what the definition of easy. Polymer, the polystyrene, its main composed is styrene, which is derived from the petroleum or natural gas, and formed by a reaction between the ethylene and benzene. Benzene is produced also from coal or synthesized from the petroleum.
How can we make it all together like that?
Well, ethylene is polymerized either by heat or by an initial such as benzoyl peroxide to form the low density, loosely attached cell. Expanded polystyrene is noted for. Polystyrene must be first be suspended in water to form droplet. A suspension agent is then added to them to hold up the drops, prevent them from sticking together. The bales of the polystyrene produced by the suspension polymerization are tiny and hard. To make them expanded, special blowing agents are used.
So all that connected by polymerization?
Yep. And this is a simple pictures about the machine which we are using to make the executive cup you hold.
They call it molding machine?
Yep.
So how are you gonna make it?
We just put the polystyrene bean, which is hard, and hot air to pre-expand it. Then we make them together. We make the pre-expanded bean together. After that, we can mold it in any shape you want, just like this one you hold.
Oh, that's so interesting. Do you think it's a good idea to use that insulation in building because my uncle gonna move to Chicago next year?
Yeah, we can make some model house if you help me to do that, or it's already my project to do that.
Sure, I'm master in building the model house, I hope.
Okay, let's do it.
Okay. For the model house, all you need a ruler, some tape, some wood, and a form because you need to prove the insulation of form better than wood at weight shape. Some glue, scissors, a pencil, and some colored paper so you can decorate your house. Besides that, I have this big box continue at the base of the house, this at the bridge, and we're gonna put the inside as insulation. We're gonna have two boxes with at two model house, one using wood, and another one gonna use with the EPS to see which one gonna keep better insulation. So you gotta measure all the size that you want to see how big the house gonna be. Glue that with wood and the form, decorate that, and here we go. I have the two house here for you. This is the house with the form insulation, so it's quite lighter. And this is the wood house, so it's a lot heavier. So now we're gonna experience to see which house have better insulation by putting a bigger with hot water in that. It's supposed to be a base here, but now we're gonna make it empty to put the water in here at a heater. And then since it's freezing outside, we can put it outside for a couple minutes to see which how I wanna keep it warmer. Let's do it. We're done with boiling the water, so now we're gonna put the water inside the house at the heater to see which one has the better insulation. So here is the water after boiling, so we're gonna put inside the house at the heater.
Come here, let's see how hot it is. See here, it's 61. It's also 62. So it's almost the same and the same amount of them. And
we're gonna put this inside the house.
Oh, do you see what's inside? This is inside. We have all around the wood and polymer around in here. So it's all the same thickness and different material. Everything else is all the same. So
yeah, and we have this with the form and the same thickness. So we're gonna put it in here.
All right. All right.
How long should we wait for this to finish?
I think 5 minutes is enough. Let's go inside. It's cold here.
I know. Let's go inside.
See you.
So why do you think EPS is a really good material for insulation? What's the reason?
Well, it's based on the structure of EPS. Like we have mentioned before, the EPS will be pre-expanded before it makes a form. Well, when it expanded, it will get the structure of the cell structure. The cell structure is contain 97% of the air, and air is good insulation material. And also we can see EPS has a lot of other benefit for the insulation structure, like its low heat conductivity based from the air, and highly resistant to the water penetration because it's the polystyrene which seals them. It's really stable, and high compressive strength, lightweight, easily bounded. I'm going to show you this part. This part is talking about the material which you're using to build the house.
So the K here is the thermal conductivity, right?
That's correct.
So you want to have the lower K for a better insulation?
Yeah, correct. And we can say either the expanded polystyrene or the extruded polystyrene, they give really low K.
But I see the SPS here, the extruded polystyrene has lower K here in this case. So why don't we use that?
It's about your cost. You don't want your house to be really expensive, right? Because extruded polystyrene will cost a lot than the expanded polystyrene. And also, I'm going to show you another picture about the 24-hour record for the house in July and January.
I see.
Well, the wave line is a concrete wall which don't have the insulation, and the flat line is a wall with EPS and XPS.
It's changing a lot for the concrete.
Yeah, but now change a lot from EPS and XPS. So why don't we use some cheap material?
That's true. What else about EPS you can show me?
Well, I think EPS can be really good material for reduce global warming.
Really? I didn't know about that.
Yep. Heating and the cooling account 50 and 70% of the energy cost of the house, and the U.S. consumed cost $40 million in air conditioning.
$40 billion?
Yeah, that's correct. Wow. So our theory is based on the less you produce the heat, the less the global warming may be. So if every house use a EPS, we'll save 200 times of the energy and 400 times of the carbon dioxide every year.
I definitely want to tell my uncle to use this at installation.
Yeah, that's
if
correct.
The experience went well. So let's go to see the house. Do you think it's enough time?
Yeah, sure. Let's go and have a look.
Okay. Okay, it's time for us to see which one is better. Want to see the wood first?
Yeah.
Okay. So we're gonna see what's the temperature of the water.
Let me see. It's 42, 43.
Okay.
Oh, it's quite cold in Texas.
What about this one?
48, 46. Well, just after 5 minutes, the temperature for the wood go down to 42, and temperature for the polystyrene is still 47. That's a big difference for your cap. Well, that's our part of our project.
Okay, so I hope I can persuade my uncle to use this at installation in his house in Chicago.
Definitely.
Maybe we can do that.
Are you ready?
Yeah.
Okay, let's sing. We wish you a Merry Christmas. We wish you a Merry Christmas. We wish you a Merry Christmas.